so here we go. What if I were to ask you for thinking about everything that you've learned this week? Oh, Amador, set me up for this problem. I didn't even think about that until right now. What is 25 times 36? Do you remember who talked to you about this morning? So it's okay if you don't remember because he did it really fast. He didn't draw anything on the board to help you sort of think about why he was doing it. Remember how important it is to model? When he was saying it, was like, well, model that, then they'll see it better. Model that, model that. That's a really good hint for you in your class. Don't do number stuff up here. Don't do it out here in the air. Model it on the board. So he said something about doubling and halving. Do you remember that? So could we think about 25? Now, 25 times 36, you could do the algorithm. You can do all that, right? A lot of steps. Or we could use that strategy that he talked about. Could I double one of the dimensions? So if I have a 25 by 36, can I half this guy and tuck that piece down here? What do I end up with? What does this end up? Is that a 50 by, what's this little piece up here? So I just ended up here with a 50 by 18. That's nicer, but not nice enough. Go for the gusto. Can we do that again? Can we cut this guy in half right here and tuck this one down here, and so I end up with this long guy over here? What would that long guy do? I cut 18 in half. That doesn't look very in half. Can you pretend that's half? So that's 9. And then what is this doubled? 50 doubled over here is 100. What's 100 times 9? 900. So I'm going to get rid of this stuff really fast because I don't want that to go into the water. And so if I've got that 900 over here, that's our first problem with the string. What if I were to ask you for a fourth of 36? Hey, we've been thinking about 1/4 of stuff, right? Yeah? How do you find what is a fourth of 36? That's not too bad. You have some relationships. Did anybody take a half of 36? What's that? Is that 18? And then we can do a half of that to find a fourth. And so what's that? Half of 18 is 9. That'd be a fine way to do that. This is the next problem. What is 0.25 times 36? Don't say it out loud. Oh, man, now we're going to do the butt cheek method. Or do we? So my wonderful pre-K2 friend here just said it's still 9. Justify your reason.
Because a fourth is 25th of 100.
A fourth is 25ths of 100, which is this number here, 0.25. That's 25 hundredths. So you're telling me that these two here are equivalent? So 0.25 times 36 is simply 9. Don't you wish you knew that? I wish I would have known that. So there, could I find 3/4? If I know that 1/4 of 36 is 9, could I find 3/1/4? If 1/1/4 is 9, could I find 3 of them? What are 3 9s? You just did that, but you also just did that. Either one, take your pick. They're both nice. Okay, one more. What if I were to ask you for, let's do a similar one. 0.25, let's just practice a little bit. 0.25 times 24. Don't say it out loud. Don't say it out loud. Don't butt cheek. What are you thinking in your heads? Don't give it away. Don't tell me the answer, but what are you thinking? Just give me a broad general. What are you thinking? 1/4? Are you thinking 1/4? What is a fourth of 24? 6? Is that right? Now, you can feel free to do it at somebody's typing the calculator. That's actually right. So what if I were to ask you for 0.26 of 24? Do I need more or less? More or less? If this is 25 hundredths of 24, but now I want 26 hundredths of 24, how many more hundredths do I need? I just need one more hundredth of 24. Now I need to do a little place value. What's a hundredth of 24? I'm going to whip through this a little bit because we would have done some more work on that, but can you do a tenth of 24? That would be 2.4. So then another tenth of that, that's 0.24. 1/100th of 24. I just did a little place value shift. I just shifted it a little bit. 0.24. I'm agreeing right now we have not developed that. I did not construct that well, so you're starting to blame me on that. But if I know I need one more hundredth of 24, I've got it. So what do? How do I find this 0.26 times 24? How do I find 26 hundredths? I got 25 hundredths. I got 1/100th. What do I need to do? Just add them together. Put the 0.25 and the 25 hundredths and the 1/100th together to get the 26 hundredths. And so what is 6? This is hard. I know. Hang in there. You can do it. What is $6.24? And we are to that place I love where the question is the answer. What is $6.24? It's $6.24. Yeah? Yeah? All right, guys. That's the problem we gave Michaela. I don't know if you remember that. Do you remember Michaela with the butt cheek? We gave this problem to Michaela. Kim worked with her for about 8 one-hour sessions. She worked with her about 4 one-hour sessions, and honestly, the year was over, and she took her test, and we were done. And then we were getting ready to do a CAMPT presentation. CAMPT is the Conference for the Advancement of Mathematics Teaching in Texas. Highly recommend that you go there next summer if you can. It'll be in Fort Worth next summer. It travels between Fort Worth, San Antonio, and Houston, that other nice thing. It's really hot, isn't it? Anyway, so it'll be there. It's great. We were getting ready to do a presentation, and I was like, oh, go work with Michaela again, because I would love to get some after footage. We knew we had that before footage with the butt cheek. And I was like, I wonder if we could, work with her enough that by the end of that, we could actually get some reasoning out of it. So Kim actually worked with her for about 4 sessions, didn't work with her for a month or so. We were getting ready for camp, worked with her for 4 more one-hour sessions. Did a string like the one that we just did a couple times. The first time that she did that string that we just did, she used several little chunks. Lots of, but very, very reasoning, no butt cheek, lots of reasoning about what that would look like. And then the last time, we get a video that looks like on the string. So here's the first one. I don't really want to show you the first one, so I'm going to skip through it. But do you remember the first one? Remember the butt cheek? Okay, so I'm not going to show you that one again, even though I could. What I want to show you is that 8 sessions later, Michaela, 0.26 times 24.
0.26 times 24. Why?
Because we're trying to find a fourth of 24, and half of 24 is 12, and half of 12 is 6.
Okay.
And then I have to add 0.01 times 24.
Okay, write that down.
Smart teacher knows Michaela can't hang on to that. None of us can hang on to that kind of stuff. Write it down.
It's 24, which would be 0.24. So I have to add 6 plus 0.24, which would be 6.24.
Wow.
Cram and jam, rock and roll. Michaela struggles. Struggling student who can reason about mathematics because mathematics is figureoutable. Notice that she didn't think to herself, let's see, when she added the 6 plus the 0.24, did she say to herself, do I line these up or do I do the butt cheek? Was there any of that confusion about which rule to bring in, or was she using relationships to add those numbers together? In reality, when Kim worked with her, she's like, hey, do you remember when we thought about math in 5th grade? You can still think about math in 7th grade. You can? That was her response. No, I have to memorize all these things. I know I can think about math in 5th grade, but I have to memorize this stuff in 7th grade. So here's one message I really want you to take away from all this. That when you have kids in your room and you really teach them that math is figureoutable and they can think about it, send them out with the message that math is still figureoutable in the next grade, even if their teacher's not quite sure about that. Even if from here on out they see some things that look like they need to memorize it, math is still figureoutable. Give them that power to know that they can continue to figure out from there.